Hey guys, and welcome to Math Monday. Sorry I haven't been very active on my YouTube account. I was busy for the 2 weeks of winter break, and then I got a cold, and now I'm just recovering, as you can tell from the sound of my voice. I'm sorry if you can't understand me very well. But anyways, so yeah. For today's video, I decided let's do dilations, because that's been a very hard subject for me in math, and I know when I was younger I thought that dilations were pure evil and they were pointless and hard, and so now I'm making this video to help others who had that same problem not have as much as a problem. Okay, before we begin, let's talk about scale factors. Scale factors are what determines if the dilation is bigger or smaller than the original image, or the pre-image. Now, if it's, let's say, 3/4. Now, 3/4 is a fraction, and it's less than 1. If the scale factor is less than 1, then the dilation will be a contraction, which is, it will become smaller. Now, say if we switch the numerator and denominator, that would make it 4/3. And that would make an expansion of the dilation. The dilation would expand. Now, what if we had a negative 3/4? The negative does not determine if the after image or the dilation becomes bigger or smaller. It does not affect that at all. What it actually does is determine if the the pre-image will flip as it dilates. In this case, if we were to do negative 3/4, the dilation would be found right here. So that's what the negative does. That's what the positive or negative means. If it's positive, it will stay in the same coordinate plane that it was originally placed on. And if it's negative, it will be somewhere else. Now we're going to do this on the Orgin, because I find that's the easiest. And I've quite forgotten how to do it off the Orgin. I'd have to look at my lessons again. Anyways, so let's start with 3/4. Oops. There we go. Alright, so what we do is we get out my calculator, and we take the 3/4, and we multiply that by each, the x and y values in each coordinate for the points. Actually, let's start with the Orgin, 0, 0. Well, we all know that 0 times anything is always 0, so that will stay the same. And then next what we do is we take 14, we're going to take point C, and we're going to go 14 times 70.75 equals 10.5. So now we go back 4, 1, 2, 3, 4. Now that's 10. Then add 0.5. And that's where our next point will be. There we go. And so we'll draw a line right there. So now we know that the next point will be somewhere right here. Now we'll take A. And we know that since A has 0 as the x value, it will never move off of the y line. So it will either go up or down. In this case, down, because it's contraction. So we'll take 9, the y value, and we'll multiply it by 0.75. We'll get 6.75. Alright, so 1, 2, 3, and so that's about right there. So we'll draw the line. Sorry if my lines are very messy. I don't have, I'm using my mouse to draw, so. And then we know that the next one will be right here. So we don't even have to take these two numbers right here and multiply them. We just know because of these two numbers. We go and we draw a line. And there we go. That's 3/4 of the square. I mean, not square, the rectangle. That's 3/4 dilation of this rectangle. Alright. Now let's say the scale factor is 2. The scale factor is now 2, so now we multiply the number, each coordinate by 2. And so, again, 0, 0. 14 times 2 is 28. That would be somewhere right here. I'm sorry that my grid isn't very big. I couldn't find a grid big enough to copy onto this program. Alright, and then 9 times 2 is 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Alright, and now we know that dot is right about here. And there you go. There is our, oops, that was not very straight. Let me redo that. There we go, that's better. And there is our expansion, our dilation with a scale factor of 2. Now let's do a negative number. Let's do negative 1/2. So again, multiply everything by negative 1/2. So 9 times negative 1/2 is negative 4.5. So 1, 2, 3. Oh shoot, I'm doing it in the wrong direction. 1, 2, 3, 4.5 ish. And then we're going to do 14 divided by 2 is 7. So then times the negative 1 is negative 7. So 1, 2, 3, 4, 5, 6, 7. And there we go. There is our dilation with a scale factor of negative 2. I mean, negative 1/2. Now, a cool thing that I found, dilations are not fraction. Well, they are fractions, but they're not. Like if you had a scale factor of 1/2, you do not divide the rectangle by half. I learned that the hard way when I was in like 4th grade, because that's what I thought dilations were. Where if you had a scale factor of 1/2, shoot, where'd my mouse go? Oh, here we go. I would think that I would just divide it right here, and that would be the dilation. That is not correct. Actually, it is more like this. Here we go. take that, oops, and then you divide this into 2, and then this area right here, this area right here, would be the 1/2 dilation. That's because when you multiply each of the coordinates by 1/2, it divides in half. It divides all this and all this. I should do this in a different color. Here we go. It divides this part in half, and it divides this part in half because we're doing both x and y coordinates. We're multiplying both x and y coordinates by the scale factor. So really, if the scale factor is 1/2, you are actually quartering the rectangle, and with the after image, the dilation is this piece right here, closest to the origin. So, cool fact, if you ever have like a 1/2 scale factor, then you can do that for like a really quick cheat, and you don't have to do any like multiplying. But I would not try that trick with anything else, even negative 1/2, because it's just trickier, and yeah, it's just a little bit tricky. So yeah, there's a cool little fact right there, and I hope this really helps. I know doing this video has helped me a little bit, and so yeah, I'll see you on Monday again.